one.
It's all, I always do live. All right, good morning, e-learners. Good morning, e-learners.
What's up?
All right, grab your pens, look in front. Let's grade this puppy. All right, so number 2 is true. Number 4 is true. Number 6 is false. Number 8 is false. Number 10 is true. Okay, knock off the chit chat, please. Number 12 is 7. Number 14 has no solution. Number 16 has no solution. Apparently, these people don't know how to pick a good domain. Number 18 is no solution. Number 20 is 24. Number 22 is no solution. Number 24 is 287. Number 26 is 32. Number 28 is 16. Number 30 is 23. Number 32 is 6. Number 34 is 6. And the last one is 3. Count up how many you got wrong. Put it on the top of your paper. Same 2 people as always. Geometry portion. Somebody's. All right, everyone else, yes, ma'am.
What did you say, 12?
12. What's the answer to 12? Somebody. 7. All right. While they're collecting and passing things out, you shall look. Oh, look at this beautiful homework. I'm not going to tell you who this is in this class, but somebody turned that in yesterday. Look at that. That's a work of art. That's what your homework should look like. All right. There's only one problem with this is what?
They checked it.
Well, no, I didn't. So when they were grading, what did they do wrong?
They checked it.
I don't need to see that, right? I know you guys really want to say, well, I got it right, got it right. I want to see the one you got wrong. Let's see if we can figure out. Where's their mistake? There's their work. That's why you put your work, because we can find their mistake. Where's their mistake?
The 14,
14 plus 7.
Oh.
What did they write? Okay, so is this, I don't know what I'm doing type mistake or a silly mistake? This is a silly, this is a -1 silly mistake. This is not -4, you don't have a clue of what you're doing, right? So that person right there tells me I know what they're doing. They got most of the other ones right, so clearly this was just, brain fart. I don't know what, everyone loses their brain occasionally. All right. Here's another one. This is exactly what it should look like. They got one wrong right here. No, they even corrected it, for themselves. I don't know if you can see their work, but they got 45 minus 19 is 36. Is that right? 45 minus 19, is that 36? Is it? 8 plus 7 is 15. I want to see, let's see, 45 minus 19. 45 minus 19. 9 from 5. Well, we got to borrow 1, so that's a 3. Jackson, paying attention? 9 from 15 is, but 1 from 3 is 2. There's a mistake. 26. I mean, it's the same basic mistake. They just got a silly mistake. They know what they're doing. I can tell from their work they know what they're doing. I will take care of you this year if you show me you know what you're doing. If you don't show me any work, I can't help you. I'm going to put -4 and take away all the points because you haven't shown me anything. Quiz tomorrow. We'll talk about at the end of class. Here's your homework. Copy down. Looks like a lot of homework. Must be easy if I assign that much.
We have to show our work for this.
I'm gonna throw something at you.
We
always have to show
our work. How do you do work for greater than less than?
Yeah, how do you?
Oh, for that, well, you're gonna see as it goes on. Obviously, if there's just two numbers, there is no work. But no, but you'll quickly see that it moves away from the obvious ones to where you actually have to do a little bit of work. All right, you ready? Wow, let's see, we did expressions, and then we did equations, and now we're doing inequalities. All right, we'll talk about the objectives when we get there. Last class, or last few classes, we talked about inequality, right? And we said that an equality is defined as two expressions that are equivalent. 2 plus 3 is my first expression. My second expression is 1 plus 4. Those, not the numbers, clearly the numbers are visually different, but their values. 2 plus 3 is 5. 1 plus 4 is 5. Therefore, if their values are the same, we can put an equal sign in between. Make sense? So what happens when the left side is not the same value as the right side? Did I tell you yesterday my dog can do this? Right? If I take little pieces of cheese and I build little piles, and I put a small pile right on the left side, and I put a big pile on the right side and let my dog go, guess where my dog goes? The big pile. You tell me that dog isn't doing math. That dog is doing math. The dog knows I should go to the larger pile first. That's a mathematical concept, right? Maybe the dog isn't literally counting or adding, but they are considering the value, the area, the volume of the size of the cheese, right? So what happens when the values are not the same? We are now in the world that's called, we're not in the equation world, we are in the, go ahead. We are in the inequality world. Okay, write this down, box 1. An inequality is a mathematical sentence. Remember, yesterday we defined an equation as a mathematical sentence. But for an inequality, that indicates how two expressions are not equal. It doesn't just say that the two expressions are not equal. It expresses how they're not equal. In other words, it's going to tell us which one is the big pile of cheese, which one's the small pile of cheese. Now I'm hungry. I will, but I'm thinking of a cheese stick now.
Jack has like 4 inch lunch.
I could live off of cheese sticks.
Me too.
I gotta just like peel them and eat it.
All right, inequality is a mathematical sentence that indicates how two expressions are not equal. It's the how part, and I made it red and underlined it. That's important. Every year, I get kids that make it into 8th grade that can do this, but they can't read this. Not the words, but the inequality symbols. I will literally have kids that will look at the symbol and say, I don't know what the symbol is, I just know how to use it, right? If you're one of those persons, well, hopefully today, now, I fixed that. If I had you last year, I said the same thing in course 1. So hopefully, and I called them my math gang symbols, right? And, all right, these are your inequalities. This is the, see what I mean? I got literally the first kid that said, gave me the wrong name of it. Yet I guarantee you they probably know how to use it. This is the, you're wrong. This one is what? This is the less than. This is the,
I don't know.
we got work to do. All right. What's the last one? Now, technically, this is an inequality because it's saying that the two sides are not equal. This does not tell us the how. So I put this one in there just so that you could be familiar with it. We don't necessarily consider the last one, the does not equal, to be an official inequality. But we could at least use that to show that the two sides are not equal. These 4 right here from left to right are the less than, greater than, less than or equal to, or greater than or equal to. So let's take a moment, since clearly I don't have one, but I have many people that don't know how to read these, to learn how to read an inequality. We read, at least in English, from left to right. Right? That's not true in all civilizations. Some civilizations read from right to left. right? But in our language, we read from left to right. We will always read inequalities from left to right. So as we read from left to right, no, I don't have the 3rd and 4th grade teachers' little alligator symbols and all this stuff. If we go from left to right, we come to the tiny part or the big part?
Tiny part. Right.
So this is where math teachers kind of, and this is why I assume that most teachers use the alligator thing, because it makes a bit more sense. But we come to the pointy part of the inequality, not the mouth of it. The pointy part, if that makes sense, right, we would call it the vertex, right, of the shape. If we come to the vertex or the pointy part, we call that the less than symbol. If we come to the mouth portion first, going from left to right, we call it the greater than symbol. Okay, so that is the less than symbol, right? Box 2, write this down. Remember, we go from left to right. This is the less than symbol. I came to the vertex of the pointy part. Okay? For instance, 2 is smaller than 10. If you need to write the example, write the example. Its opposite is there. Notice if we go from left to right, we come to the open portion. This is the alligator's mouth, according to 3rd grade teachers. Nothing wrong with 3rd grade teachers. This is the greater than symbol. So an example would be that 15 is bigger than 14. Notice where the opening is. The opening is always towards the larger of the two numbers. But we read them from left to right. 2 is less than 10. 15 is greater than 4. All right, how do we use the less than or equal to or the greater than equal to symbol? Well, if it was just the less than symbol, it makes sense. It would be used the same way. What does the equal do? Go ahead.
It means that it's either equal to or
It's that. It could be equal to. I literally could have 2 is equal to 2 and use this symbol. So, less than or equal to. 2, well, it's not smaller than 2, but it is equal to 2. So, I could use this symbol. I could replace this for this if I wanted to. Or when the two numbers are exactly the same, I can use that. You're like, well, why not I put an equal sign? Well, you'll see why this year. This is generally how you would see it used. But like I said, it's at least at this point, without any further explanation, you're like, why would I need to use this symbol, the less than or equal to, rather than just the less than symbol? You'll see why this year when we solve these inequalities. And then its opposite is the greater than or equal to symbol. So 2 is also greater than or equal to 2. That's kind of crazy. I can use any one of these two symbols for 2 and 2. But generally, we would typically see with the larger number next to the opening, the smaller number next to the vertex of the point. Okay. Now, I just made a big deal saying we didn't reread these from left to right. Yes? Turns out you can also read them from right to left.
technically I was correct.
If all you have is the symbol, just the symbol and no numbers, read it from left to right. But check it out. E-learners, I'm going to the very first one. If I read this from right to left, what does this say? 10 is bigger than 2. So, technically, if it's a full inequality, you can read it in any direction. But the opening portion is the greater, the vertex portion is the less than. If I read the top one, e-learners, from left to right, I would say 2 is less than 10. If I want to read it from right to left, I would say 10 is greater than 2. Who's lost on that? Okay, good, because that's a pretty simple concept, right? Those are our inequalities that we'll be using. We will use that equality sign with the slash through it some occasion to simply say not equal to. But remember, an inequality by definition states how the two numbers are related. Which one is bigger, which one is smaller. So that symbol right there doesn't get much love, but it does mean not equal to. We okay? Moving on. First game that we will play today And the people that already looked at the homework already say, wait, there's no work here. I will give you two numbers. And I will give you the option of either putting an equal symbol, a less than symbol, or a greater than symbol. It is literally that easy, right? So that's why they're asking, wait, what work is here? Yeah, there's no work here. Which is the bigger number? Which is the bigger number? So what symbol am I going to use? Remember, if it's just the symbol, we read it from left to right. So I'm going to use that symbol. Now, other people will say, well, could I write it 14 and 21 and use that symbol? Yes or no? I could, right? So that's your option, right? It is your option of what order you write those numbers in. All right. What symbol am I going to use? We're going to let Jackson answer all the questions today? Is that the deal?
No.
Uh-oh. So this is your first one where, okay, granted, it's not a lot of work, but there's a little bit of work here. So notice you're like, well, I'm not even sure what they want to do here. Notice there's a big space right here, right? What they're saying is, well, you got a left side and you got a right side. The left side is equal to, and the right side is equal to 5. So what symbol? All right, you get how that's done. Now they will get slightly more complicated than that, but not too bad today. Okay, so box 3 is green. Typically we do some together, but since this is an easy concept, do this by yourself. You have, I don't know, 30 seconds. Go. 30 seconds. For those of you doing your homework, you also have to fill this sucker out as well too. We're doing box numero 3. Yes. Okay. Anybody need help? Which one? No. I mean, you could try to find that in your book. It's under the section. You see, you can figure it out from there. Oh, very nice. So the question was, he's trying to do his homework, and he gets to one that he has no clue what to do. I said, well, you could open your book and look at the examples. And then he opened his book with the example, and he figured it out himself. It's not that I am encouraging you to do your homework during class, which I'm not. I'm just saying for those of you that are like, I kind of got this. I don't need to go at the pace that you're going on. I can go faster. Knock yourself out. You just have to pay attention in class. And fill out the sheet. We okay? Your 30 seconds are up. All right, Hannah, upper left one. What's the symbol? It would be less than. That is correct. All right, Callie, read that first one from right to left. Read the first one from right to left.
25.
Right to left.
26 greater than.
See how she did that? Be comfortable with reading it both ways. Very good. Olivia, next one. What symbol? Okay. Less than or equal to was not one of your options. But yes, that would be true if it was one of your options. Your options were equal, less than, or greater than. So which one would it be? It would be equal. Okay? And Aiden, last one. Yeah, because 17 and 82 is what? 90, 99. So it's got to be greater. We okay? All right. For homework, they give you 3 numbers. And they're like, well, how in the world do you do this? These are called, and we're not going to hear this until Algebra 1, these are called compound inequalities. A compound inequality is 2 equalities put together. You're like, what? Well, let's think about it. If we read this from left to right, is 18 bigger or smaller than 46? So we could, if it was just 18 and 46, put what symbol? Less than, right? 18 is smaller than 46, right? Now let's look at the middle one and the last one. If it was just 46 and 32, what symbol would we use? We would use a greater than symbol, okay? So, well, that's true. That's true. That's true. That seems like a lot of work, right? If I go through all the possible combinations, right? That's true. That's true. Boy, looks like there's going to be a lot of work. There's an easier way of doing this, right? And that is simply, well, I guess this is box 4, by the way. Write all the possible combinations. Do that for me, please. And there's the answers, by the way. But you write the answers and then check your work to my work. You'd have to compare 10 to 50, and then compare 10 to 20. And then compare 50 to 10, and then compare 50 to 20. And then compare 20 to 10, and then 20 to 50. Those are all the possible combinations. And then I will show you the easier way of doing this. Who's lost on this? All I'm asking you to do is take those two numbers, wait, there's 3 numbers, so you gotta do 2 at a time, and compare using inequalities. You see 10? I want you to compare it to 50 using one of these symbols. So, write the 2 numbers. Okay. Now you just compare 10 to 50. Now I want you to compare 10 to 20. So we're done with 10. Now let's do it to 50. Compare 50 to 10. Now compare 50 to 20. And then do it for 10 to 20 to 10 and 20 to 50. Yeah. What, it's in your locker? Go ahead. All right, anybody tired of doing this? That seems like too much work. There is an easier way of doing this, okay? Instead of doing 6 different comparisons, we can do it with 1. All right. So, here's how it's done. Write them in order from least to greatest. What would it be? 10, 20, 50. 10 is what? Bigger or smaller than 20? 20 is what? Bigger or smaller than 50? There you go. That expresses all 6 of these. I gotta stop writing red. It's hard to see. There's my black. We okay? This is called compound inequality. Compound in chemistry is a mixture of chemicals, right? Compound inequality is a mixture of inequalities. All right, so I can use inequalities to show the relationships between 2 expressions, true or false. Big words for I can assign one of these math symbols if I give you 2 or even now 3 numbers, yes? All right. This is the one that will require a bit of explanation. So if you weren't paying much attention, now you got to pay attention. Okay? All right. Graphing numbers. I got 3 numbers here, and I want to graph them, right? How do I do that? Somebody from last year? How do you graph 1, 5, and 2? What do you need, Jaden? Okay. What else do you need? I want to graph them. What do I need? I know those aren't points, so I don't need the Cartesian plane. What do I need? I need a number line. What's a number line? Don't overthink it. Corrected? I need a line, right? Well, there's my line. Now what do I need? I need numbers. So I'm going to put 100, 120, 130, 140. Yes? And I'm going to graph those numbers. Correct? Correct? Well, who's saying no? So I'm going to put 100, 120, 130. I'm going to graph those numbers. Yes? Come on, Gabby. Yes or no?
Wait, what?
So I know you're not paying attention. So I'm going to put 100, 120, and 130. I'm going to graph these 3 numbers. Yes? That's what I'm trying to get at, right? How do you pick your numbers on your number line? Who's got a good idea? Now Brecken's got it figured out. Right? What do you think, Callie? I could use the least and the greatest number, right? Wouldn't that be the most efficient way? Sometimes it's not because there's crazy number of tick marks in between. Other times it makes a lot of sense. Who's lost what I'm trying to explain? We got to put three numbers on a number line. So we got to assign numbers. Well, if you start at 100, you're never going to graph any of these numbers. If I start at -40, I'm going to have a lot of tick marks. So to be efficient, one way is to choose the smallest and the biggest number and make those your two endpoints, right? Where you start and finish from, and then put the right number of tick marks. Sometimes you run into problems there because, right, either it's a weird number of tick marks or you run out of space. So another method is pick friendly numbers between them. For instance, I don't know, instead of starting at 1, I could start at 0 and go all the way up to 10, right? 5. There is no rule of how you do this, right? It's not that it's wrong if you go from -10 to +10. Well, that's the wrong answer. No, you can still graph. But if you want to be efficient, you choose the smallest and the largest, unless they're weird, right? If it's 2.5, I'm probably not going to put a tick mark on 2.5 as a starting point. I'll probably start at 2. Okay? Does that make sense? Okay, so I always, you typically go from the two extremes. So the smallest number to the largest number. Smallest number, largest number. How many tick marks in between 1 and 5? Don't you really want to say 5?
Yeah.
But if you think about it, you already got 1 and 5 figures, right? You already got 1, you got 5. It's actually 3. It's not even 4. So just be careful with your tick marks and then try to make them evenly spaced. Try your best. If you got graph paper, it makes it pretty easy, right? All right. Now, those of you that had me last year, you already know. Do the points go above, on, or below the number line? You paid no attention last year.
On.
Do the points go above, on, or below the number line?
On.
They go on the number line. Your points need to be circles, right? So let's see. How many circles do I need? Well, there's 3 numbers, so I need 3 circles. So a circle on 1, a circle on 2, a circle on 5. I'm done. That's how you graph. Okay? All right. So there's our long explanation of how to graph. Could you do this by yourself? Is this painful? Do you run out of space all the time? All the time. You got to be careful. Be careful. Think. Try to do a little bit of planning before you erase 4 times. All right. So I'm sure you're okay and you're ready to move on, right? Just like this girl. Yeah, she looks like she's ready to go. All right. Here's the game. The game is we're not going to be graphing individual numbers because what's the lesson today? It's inequalities. The difference between an equation and an inequality is equal means one number. 2 equals 2. Right? But 2 is greater than how many numbers? How many numbers is 2 greater than? Well, that'd be whole numbers, right? But technically it's an infinite amount, so we got to graph that. So this is the one issue for graphing inequalities is it requires far more work than equations. We don't graph equations, or we don't graph a simple expression that equals another one. We will eventually graph equations, like linear equations, quadratic equations, but we typically don't ever graph our answer to 2 plus 3, and the book says graph your answer, right? 2 plus 3 is 5, you're done. But when we have an inequality, right, we might want to graph our answers because there's more than one answer. 2 is bigger than, well, a lot of numbers. All right, so last class, we did this thing right here, remember? I gave you an equation, I gave you a domain, a restricted domain, and you figured out the solution set. Remember doing that? Remember doing that one where there actually were 2 answers, right? So with an equation, typically you get 1, maybe 2, answers. With an inequality, you can have lots of answers, which is why we need to graph. This is typically not 1. So today, I'm going to give you the same basic thing. Granted, the numbers are slightly different, but it's going to be an inequality. So I think you can kind of figure out that we could potentially get lots of answers. We're going to graph those answers. Okay. And also, as we go forward, whenever we solve inequalities, we always graph the answers. We're not doing solve. So don't panic. I'll walk you through the process. It does sound complicated. It's not. Look at that restricted domain. It's not very restricted. There's a lot of numbers there, right? Do not panic. Yesterday I said you got to find the one answer and you're done. That's only for equalities. Now it's inequalities. Lots of these could be the answers. So let me try to walk you through. First off, do you visually see, this is box 5. Do you visually see the inequality? Right? It says 19 plus x is greater than 24. 19 plus x is greater than 24. Okay? That's what I'm going to plug these numbers in one at a time. One at a time. Is 19 plus 1 greater than 24? Nope. Is 19 plus 2 greater than 24? Is 19 plus 3 greater than 24? 19 plus 4? 19 plus 5? It's greater than 24? It is 24, right? But it's not greater than. If it was greater than or equal to, you put a guess there. What happens at 19 plus 6? It's greater than. That's your first true. But put your thinking cap on. What would happen to any number bigger than 6? It would be greater than. So do you need to actually do 7, 8, 9, and 10? No. As soon as you find that tipping point to the number that makes it true, then you can assume what? That any number larger than 6 would also make it true. Does that make sense? Now remember, it could have been a less than symbol. You'd still do the same process. You're going to find that tipping point. If it was a less than, you would have had what? True, 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 false. And then you could stop. Who's lost on that idea? If this had been a less than, this would be true. 19 plus 1 is less than 24. So this would have been, if that was a less than symbol, true, 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 false, and then you could stop. Guess what we're going to graph? You think we're going to graph the false answers or the true answers? We're going to graph the true answers. So which ones are the true answers? You hear what she said? 6, 7, 8, 9, and 10. That's what we have to graph. 6, 7, 8, 9, and 10. All right, so what's our graph going to look like? A line. What numbers are we going to start from? We could go 6 to 10. Some people might do 5 to 10, right? It's up to you. Some people might go 0 to 10. I probably wouldn't do that, but it's true. It would work. So I need a number line that at least goes from 6 to 10, right? Could I go from 1 to 10? Guess why I went from 1 to 10? No, because I was lazy and I went on the internet and I said, give me a line that goes from 1 to 10. And then I can use it for almost all the problems. So don't follow my advice. I just did this to make it look nice and not have to recreate that. Where do my dots go for this? Go ahead.
On the line.
Yeah, for this problem.
Oh.
6, 7, 8, 9, 10.
Right? 6, 7, 8, 9, 10. I got like 4 people talking today. The rest are kind of sitting there. If you're sitting there and you understand this, we're in a good spot. If you're sitting there, you're like, you lost me 10 minutes ago. We got big problems. There is your graph. Technically, this is the answer. This is scratch work. This is your answer. Your answer to the problems, I think almost all problems, starting on numbers 25 and above, all say graph the answers. Let's do one. Box 6. Let's do one. Let's do one. Just one. Hey. Let's see if you're right or not. Okay. Does 1 make this true or false? What? False, because 1 minus 1 is 0. Wait. 0 is smaller than or less than 3? Mm-hmm. Who was saying false? And why were you saying false? What's 1 minus 1?
0.
Is 0 smaller than or equal to 3?
Yeah.
It's not equal to 3, but it certainly is smaller. That's a true statement.
Oh, why?
So this one's going to go true, 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 true. Eventually, we're going to get to false, and then we can stop. Okay? Starts with false. Eventually, you look to see where it says true. If it starts with true, you're going to keep going until you get that first false. All right, what's the next number we're plugging in? 2. 2 minus 1 is?
1. True.
And 1 is definitely smaller than 3. So that one's true. How about 3? 3 minus 1 is 2. 2 is still smaller than 3. How about 3?
True.
I'm sorry, 4.
True.
4 minus 1 is 3. 3 is not smaller than 3, but it is.
Equal to.
Everybody see that one? That's the tricky one. What happens when we do 5? Can we stop there, or do we have to continue?
Stop
We're
there.
going to stop right there. So what numbers are we going to grab?
1 through 4.
So what's your number line going to look like?
Line from 1 to 10. You got dots.
Well, that's what mine's going to look like. What's yours going to look like?
1 through 5.
Okay, 1 through 5, 1 through 4. Like I said, I use the same one over again. So sue me. All right, 1, 2, 3, 4. Now I'll grant you that mine is inefficient. My dots also are not lined up as I look at this perfectly. PowerPoint gives me some problems sometimes. I truly meant for those dots to be perfectly lined up. What do I mean by that? Here's the tick mark. I would love for your 0 or your circle to look like that over the tick mark. Okay? Notice mine is way off, right? But I did write the answer right here. So even if you're sloppy like me, and I'm doing it on PowerPoint, I just couldn't line up this and that really well. All right. There's my lame excuse. Yes?
Wait, so you want the numbers on the and then the little circle on the text?
You got that. You see the tick marks?
Yeah.
So if 8 was one of the answers, my circle would go around it like that.
Okay.
Okay. True or false? The red part, or pink part. All right. Let's talk about the. I'm sorry. There's one more last idea. Last idea. Oh, what am I trying to say here? So the next idea. There are a couple questions. Instead of giving you a restricted domain, you listening? They're going to say consider all the whole numbers. Where do the whole numbers start at? 0, and then they go all the way to infinity up by 1. Right? Infinity is not a number. It's just the idea that numbers keep getting bigger. Okay? So if the replacement set is like all of the whole numbers, this is questions number 37 and above, right? It says the replacement set is now all the whole numbers instead of the previous one was a restricted domain. Okay, so how many whole numbers are smaller than or equal to 3? 0 through 3, that's what they want you to grab. Okay, so 0 through 3. So remember, these would be all of the whole numbers, and the only ones that work there would be 0, 1, 2, and 3. Who's lost? Okay. If the whole numbers are your replacement set, what's the answer to this one? What's the first number? 7 all the way through infinity, positive infinity. So how do you write that as an answer? Okay. Well, what's the first number? What's the second number? Second number. Third number.
9.
And then you're going to put
Dot, dot, dot.
dot, dot, dot. So there's your first answer. This is one where you don't have to graph. There's your second answer.
Oh.
Make sure you're looking at this, Jenna. Make sure you're looking at this and you understand this. Notice it didn't say we had to graph. It just said, what are the solutions? Plural, because there's more than one. Let's do one of these and we're done. Right, this is the last box, yes, no? Okay. So if the replacement set is the whole numbers, be careful, look where I put the variable this time. So on the right side. So now we got to read from right to left. What does this say? X is what? Smaller than 4. What are the whole numbers smaller than 4? No. No. 0. Remember, 0 is part of the whole numbers. All right? Oh, and just to make it clear, I never yell at anyone. I'm just doing math teacher stuff, right? There's some things I'll say, no! They're like, oh, he just crushed me. No, that's not it. All right. So 0, 1, 2, 3. Yes?
Yes.
Last one. 0 is bigger than 66. Yes? So what's the answer? Okay. What does this line underneath mean?
Less than.
So
Greater than.
actually, the first number would be 66.
What? Oh.
That's what the line means equal to. Give me the numbers that are bigger or equal to 66. Therefore, my first number is 66. So 66. Now, how many numbers do you put before dot, dot, dot? There's no rule, but generally it's 3. Most of the time, you'll see 3 numbers and then a dot, dot, dot. So 2 numbers, you don't know what the pattern is. After the third number, you can recognize a pattern. So, well, you put 4, yeah, because there were 4 answers here, not because I put in 3. But for the ones with a dot, 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 you have to have at least 3. Who's lost? All right. Apparently I lied. There is one last idea. Oh, compound inequality again. Okay. If the replacement set is the whole numbers, what would go right there? Is Breckton right? He said 5, 6, 7, 8. Is he right?
Yeah.
Yes.
He's right. So 5, 6, 7, 8. Compound inequality. Compound inequality. What would go right there? Oh, 2 different symbols.
4, 5, 6, 7, 8, 9, 6, 7.
Are you sure?
Yeah.
Why did you start with 4? You guys are catching on really quickly. In algebra, these will get very complicated. We're not in algebra, we're in pre-algebra. But in pre-algebra, you're just introduced to this thing called compound inequality. In algebra 1, you will solve this. It'll be way more complicated than that. All right, so 4, 5, 6, 7, 8, and we are done. Let's talk about the quiz, and we'll wrap it up there. All right. If I gave you these 2 right here, could you tell me which one is numerical and which one is variable? That will be on the quiz, literally. You just got to look at the expression and tell me the top one is, the bottom one is. We good? All right. If I gave you an expression and a value for that expression, could you evaluate it? Okay. Could you use PEMDAS to simplify this expression?
Yes.
And then lastly, could you determine if this is one of those true-false ones? Right?
Yeah.
The only thing we did today was basically the same thing as this, with a restricted domain, figure out which ones are the answers. That's what we just did. Could you figure out which ones are the answers? I don't think I have you graph on the quiz, so let's just figure out which ones. That's the quiz. The first thing will be a 10-minute quiz. I don't know, it's 5 or 6 questions long. These are the things that will make it up. If you can do all of these right now and you're like, I don't need to study for this, you don't. If you're the kid that says, I'm sure that I need to make a resource card, then make a resource card. With it, whatever it takes to give you confidence. Remember, you can always have a multiplication table, quiz or test. You can always have a resource card. What time do we get out of here? Here 3 MSAT. What? Said what? 10:25. Back it up. Right on time. All right, e-learners, remember you will have the quiz tomorrow. It will be online. You'll see it tomorrow when I send you the link. You'll see the link to the quiz. If you have any questions, don't hesitate to ask me a question via email. See you guys tomorrow.